Okay, this is the last of the 3 videos on continuity. And so for this one, we're supposed to analyze the continuity of a polynomial and rational function. So we're looking at these in earlier videos. Remember, polynomials, this one happens to be a squared, so it's going to make kind of our x squared some sort of parabola. And we're identifying any points of discontinuity. A parabola, any polynomial does not, it's continuous for everything. So for this, there are no points that there would be a discontinuity. With the rationals, though, remember we had problems in the denominators. So for here, x equals 7 is going to be a point of discontinuity, and that's that thing where we saw this would be a asymptote at 7, and our graph would be some kind of behavior like this. So that's going to be the point in discontinuity for this one. And then here, even though this reduces, there's still going to be a discontinuity at x equals -4, because again, that's what makes that denominator 0. In this case, the graph, it would be something more, I guess -4. It would be something with a hole where it was approaching the same side, because this would reduce. But nonetheless, there's still both discontinuities. And then for number 8, this is kind of what we were looking at earlier. It's just a particular wording for the question that I wanted to show you. So determine if the illustrated function is continuous or discontinuous at the points x equals a and x equals b. If it's discontinuous, then specify which of these rules it fails first. So I kind of did that when I went through the earlier problem, but just here's a slightly more formal wording of it. So here is the function continuous at x equals a. So we look here, and you see how I have to jump the pen over that hole, so it is not continuous, and that is because f of a doesn't exist. It's not like a is down, there's not some point here, it's just a hole. So here we would say no, and then it's failing that first property is the first one it fails. And there's a function continuous at b. Nope, we got a gap. This time f of a does exist, it's right there, but the limit doesn't exist because I'm approaching 2 different values. So this is a no, and the first property it fails is 2.